Okay, today we are going to continue talking about quadratic functions. Today we're going to be looking at vertex form for a quadratic function and how the values of a, h, and k in that equation affect the graph of the parent function. So basically, if we was to start with the parent function, which if you recall, the parent function is f of x equals x squared, how would an equation that's written in vertex form affect the graph of that parent function? Okay, so here it says every quadratic function can be represented by the vertex form equation, which is a times x minus h squared plus k. The values of the parameters a, h, and k determine how the graph of the function compares to the graph of the parent function y equals x squared. Use the method shown to graph g of x equals 2 times x minus 3 squared plus 1 by transforming the graph of f of x equals x squared. So first they ask us to graph of f of x equals x squared. Well, that's easy enough. 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. Because of the symmetry that these have, then I can easily pinpoint other points that the curve will go through. And then using those points, we can draw a graph of this parent function. Okay? And then it says, stretch the graph vertically by a factor of 2. Well, we would need to stretch it by a factor of 2 to obtain the graph of y equals 2x squared. And then we need to graph now 2x squared. All right. Well, as we talked about yesterday, if the value of a is a 2, so if you think about the y equals ax squared and the value of a is a 2, then that means that we are going to need to vertically stretch the parent function by a factor of 2. So you see the parent function goes through the point 1, 1 and negative 1, 1. All right. Well, in order to stretch it by a factor of 2, we want to now go through 1, 2 and negative 1, 2. And then 2, we'll stretch that. It was 2 comma 4. Now it will be 2 comma 8 because we are stretching by a factor of 2. So basically we're taking the what the y value was when x is equal to 2 and multiplying it by 2. Again, 2 squared is 4. Well, 2 squared is 4 and 4 times 2 is 8. And so we would get that point there. Drawing the curve through these points, we can see now we have a parabola that is more narrow than the original parabola, than the parent function parabola. The point 2 comma 4 moves to the point 2 comma 8 again because that multiplication by 2 for the value of a basically means that each y coordinate is doubled for the same x coordinate. Okay. All right. Now then, it says to translate the graph y equals 2x squared 3 units to the right and 1 unit up. So we want to go 3 units to the right and 1 unit up. Okay. And that is actually where the vertex will now be located for the function that we are graphing. But again, we want to stretch it by a factor of 2. So we'll need to go over 1 and up 2. Okay. And with those 3 points, I can draw a pretty accurate graph with just those 3 points. And here we have a graph of 2 times x minus 3 squared plus 1. All right. So notice that the point 2 comma 8 moves to the point 2 plus 3 comma 8 plus 1 or 5 comma 9. Okay. Now then, might as well at this point go ahead and go over how the values of a, h, and k actually do change the function, or what are they? What do they tell us about the graph? There's some questions here we can go through real quick. The minimum value is the vertex. Okay, so how is the minimum value related to the vertex? Well, the minimum, the location of the minimum is going to occur at the vertex. So the vertex of that that last function was 3, -1. So the vertex is 3, -1, and that minimum is actually the y value of that point of 1. Okay. So the vertex of the graph f of x equals x squared is blank, is 0, 0. And the vertex of g of x equals 2 times x minus 3 squared plus 1, that vertex is at 3, 1. Okay, so to find g of 4, we would want to plug in a 4 for x and simplify. So I'm going to do a lot of this in my head. But 4, if I plug in a 4 for x, 4 minus 3 is 1. 1 squared is 1. 1 times 2 is 2. And 2 plus 1 is 3. So that would in fact mean that it does go through the point 4, 3, because when x is a 4, y is a 3. What is the axis of symmetry? Okay, so this is important here. If you remember where that function was, it's actually going to be x equal to 3. That is going to be the vertical line that would split the graph into 2 equal parts. Okay, so you got 3, 1 here. Okay, and then there and there. So it is this vertical line right here that splits the graph up into 2 equal halves, and that equation is x equal to 3. Notice it is not a coincidence. It is not a coincidence that it is the same as the x coordinate of the vertex. You see that that is going to be where the axis of symmetry is located for a quadratic function, for a parabola. Okay, and so this fourth question here is basically just kind of answering what I just was talking about there, is that the x coordinate of the vertex is also the equation of the line that is the axis of symmetry for these parabolas. All right. So what it's going to then talk about is a vertical translation. So a vertical translation just means the graph is shifted up or down. It's not changed in its shape any, but in just a vertical translation, how does that occur? And that is based on the value of k. K is what's going to shift a graph up or down. So when I talk about k, I'm talking about k in the vertex form, where that's y equals a times x minus h squared plus k. All right, so we talked about a yesterday. A is going to make the graph narrower or wider, or cause it to open the parabola to open downwards. Okay, so if a is negative, the parabola will open downwards. And if a is between 0 and 1, the graph will get wider when compared to the parent function. And when it's greater than 1, it'll get narrower when compared to the parent function. Well, now we're talking about, right now we're just talking about the value of k in that equation. And k is what's going to translate a graph up or down. Okay? So it says if k is greater than 0, it's going to translate it up. If k is less than 0, the graph will translate downwards. Okay, so that makes pretty good logical sense that when k is positive, the graph will translate up. When k is negative, the graph will translate down that many units. Okay, and k will translate up that many units when it's positive. All right, so when you look at this example here, this plus 2, that would be what is representing the value of k. And so when this graph would be compared to the parent function, what we'd want to say is that this graph of y equals x squared plus 2 is a translation 2 units up of that parent function. Okay, so that graph will have a vertex of 0, 2. It'll then go through the point 1, 3 and negative 1, 3 because every point when compared to the parent function gets moved up 2 units. So that would be then 2, 6 is another point, and then due to the symmetry, we can then say it's going to also go through the point negative 2, 6. And so this is what the graph of x squared plus 2 would look like when compared to f of x equals x squared plus 2. Again, this is the parent function here. This is that this table is of. And then when you look at g of x equals x squared plus 2, what you would notice there is that all these points, these y values, are 2 units bigger than they were for the parent function. And therefore, you get points that are 2 units above where they were for the parent function. And so I guess they technically want me to draw the parent function here, which I'll do a very rough sketch. It's a little too narrow there, so, well, go ahead and plot the points. Okay, so again, there's the parent function, and then down here they wanted us to graph the transform function. Okay, and so then that graph would look like that. All right. Okay, so here they are continuing wanting us to translate a function upwards or downwards. Again, they want us to input the values for y for the parent function here, and then below there put them in for this transform function. Of course, it'd be very easy for us to go to our calculator, type in y equals x squared minus 5, and then we could get these values from the table. However, what we should know, or what we know at this point, is that because this value here is minus 5, okay, then what that is going to indicate is that this is going to be a translation of the parent function 5 units down. So its now vertex is going to move down to here. These points will be moved to there, and then we got a point there and a point there, and so that curve will look like this here. Okay, and then so it's asking, so again, just regraph that here real quick, that this transform function. And it says it has a minimum value. Well, the minimum value is occurring at the vertex. Okay. And so if we look at the coordinates of the vertex, that point right there is the point 0, negative 5. And therefore we can say that it has a minimum of negative 5. So the y coordinate is actually what would be considered the minimum, and it occurs at x equal to 0. So this function has a minimum value of negative 5, and that minimum value occurs when x is equal to 0. The axis of symmetry is the y-axis, as we can clearly see, the y-axis right there. Now then, and what's the equation of that? Well, the equation of that is x is equal to 0. All right, and then next up is a horizontal translation. In other words, how do you shift the parabola left or right? And with no change to the shape of the parabola. So it has the same width as the parent function, but it's just a shift left or right. And that's going to be based on what the value of h is. So if h is greater than 0, then that's going to translate it h units right. So positive, when h is positive, the graph is going to shift to the right. Again, that makes pretty good logical sense, as we should think of a positive value being something that would shift to the right. When h is negative, or in other words less than 0, it's going to shift h units left. Okay? So in this case, you got the x minus the 1 squared on example A. Now here is the trick. Here's the thing about h. When h is positive, that means that this sign that's in front of h is going to be minus. So in this case, h has a value of a positive 1. Okay, even though that sign is minus, that means that h is positive because the equation is x minus h. Well, then h is what comes after the minus sign. H does not include the minus sign. H is what is after the minus sign. Very, very important there. Okay, so again, so they want us to graph the parent function and then graph this function as well. Well, since h is a positive 1, then we can see that it's going to shift the graph of the parent function 1 unit to the right. Okay, and so we could graph this transform function if we were just to take that parent function, y equals x squared, and shift it 1 to the right. And so that would locate the points would shift to right there. Missed that one there. Okay, so right there. And so this is what that parent or that function looks like. With that parent function shifted 1 unit to the right because h was a positive 1. All right. See, you can see that it has a minimum value of 0 because the y-coordinate of the vertex here is 0. And so that does mean that the minimum value of the function is going to be 0. The axis of symmetry is x is equal to 1 because that is the equation of that vertical line. Okay, so h shifts the graph left or right. Now then, now that this sign right now, and so looking at example B, when you see that this sign right here is addition, that means h is negative. Because in order for us to have something in the form of x minus a number and have it simplify to x plus 1, then that number after the minus sign would have to be a negative 1. So when this sign is plus, that means h is negative. Okay, so that's a little counterintuitive. You really have to focus on that and really work on remembering that. And the reason why is because the basic form of the basic vertex form is x minus h. Well, in order for this sign right here to be minus, then that h value would have to be negative, and then it would simplify to an x plus 1. Okay, so this means that it's going to shift, this graph is going to shift 1 unit to the left as compared to the parent function. Okay, so it's going to go through there, and there. So the other points will just, all the points will shift 1 unit to the left from where they were located for the parent function, and we get that graph right there. And where is this minimum? Well, the minimum again is 0 because once again the y-coordinate of the vertex is 0. The axis of symmetry. Well, the axis of symmetry is this vertical dotted line right here. And the equation of that line is x is equal to negative 1. Again, the vertex is going to be located, the x-coordinate of the vertex is the location of the axis of symmetry. Okay, so just looking at a couple of examples real quick. This one, h, what is the value of h here? What is the value of h? Well, the value of h in this is a positive 2. So this is going to shift the parent function 2 units right because h is positive. But again, you got to be careful because the formula is x minus h squared, so the minus is already built into the formula, so h is actually then going to be the 2. Okay? Alright, and so then we could graph that based on shifting everything from the parent function over 2 units. What is h in problem number 12? Well, h is now a negative 3, so that's going to shift the graph 3 units to the left. Alright, so when we put these different translations together, then we can graph something in the form of a times x minus h squared plus k. That is what we know to be a vertex form of a quadratic function. Alright, the vertex, so this is important, the vertex is located at h comma k. The axis of symmetry is x equal to h. Alright, and so then we can use this information to graph basically any quadratic function that is in vertex form. So the value of a here in this first problem is negative 3. So what we learned from 16.1 is that means that this is going to open downwards because it's going to be a parabola that has been basically flipped upside down from what it looks like from the parent function. It's also going to be vertically stretched by a factor of 3. So it's going to open downwards and vertically stretch by a factor of 3 when compared to the parent function. The value of h is negative 1, okay? Because remember, if the sign is plus, that means h is negative, just like we just talked about. And the value of k is a negative 2, so k does not work the same way. If that sign is minus, that means k is negative. And so that puts us a vertex at negative 1, negative 2. So we can go ahead and locate that point. Okay, or they have, you can see, located that point on the graph over here. There's the point negative 1, negative 2 there. And then you can see that because it is, if you go over 1 unit, then you have to go down 3 units, then that's the vertical stretch by a factor of 3. And then you can see that it is opening up downwards, and that is because the value of a is negative. All right, so let's look at one more example. Okay, so in example B here, let's go ahead and label what A, B, and or what A, H, and K are. So A is going to have a value of 2, has a value of 1, and K has a value of negative 7. Sorry. Now then, the vertex is located at H, comma, K. All right, they're asking us to plot some points here, which we certainly could type this equation into y equals, go to the table, and get these values from the table. But I'm going to go ahead and just do it a little different way. I'm going to plot the point 1, negative 7, okay, down there. All right, because we have a vertical stretch, because A is a 2, we have a vertical stretch by a factor of 2. So therefore, if I go over from the vertex 1 unit, then I need to go up 2 units to get to another point that the curve will go through. And so then just using those 3 points, I can get a pretty good rough sketch of the graph without plotting more of the points. Although the more points you plot, the more accurate your graph will be.